What if the universe is built around something we cannot see? Most of the universe may be invisible, not hidden behind distance, not too small to detect, not simply waiting for a better telescope, invisible by nature. And yet it appears to be everywhere, shaping galaxies, bending light, and quietly controlling the large-scale structure of the cosmos. If that sounds impossible, that is exactly why dark matter is one of the most fascinating ideas in modern science. It is not science fiction. It is a scientific conclusion drawn from patterns that the visible universe cannot explain on its own. When astronomers look at galaxies, galaxy clusters, and the paths of light crossing deep space, they keep finding the same problem. There is not enough visible matter to produce the gravitational effects we actually observe. The stars, gas, dust, planets, and black holes we can detect account for only a fraction of the mass the universe seems to be using. Something else is there. Something that does not shine, does not reflect light, and does not interact with ordinary matter in any obvious way except through gravity. The story began to sharpen in the 20th century when astronomers studied how galaxies move inside large clusters. The speeds were too high. According to the mass that could be seen, those clusters should have flown apart, but they did not. Later, when researchers measured how stars orbit inside galaxies, the mystery deepened. You would expect stars farther from the center to move more slowly. In the same way, planets farther from the sun move differently than inner planets. But many outer stars were moving much faster than expected, almost as if galaxies were embedded inside enormous halos of unseen mass. This was not a small mismatch, it was a pattern. Then came one of the most powerful pieces of evidence: gravitational lensing. Einstein's general relativity predicted that massive objects bend space-time, and that light traveling through curved space-time will change direction. Astronomers can now observe this directly. When light from distant galaxies passes through massive galaxy clusters, it bends and distorts. The amount of distortion allows scientists to estimate how much mass is present. Again and again, the answer is larger than the visible matter alone can justify. One famous example came from observations of colliding galaxy clusters, often discussed through the Bullet cluster. In that event, the hot gas, the dominant visible matter, was separated from the regions where most of the gravitational mass seemed to remain. In simple terms, what glowed and what gravitated did not line up. That mattered because it suggested the missing mass was not just ordinary matter hiding in dark places. It behaved like a separate component. So dark matter is not just a random guess invented to patch a broken theory. It is the name we give to a very real gravitational effect, whose source remains unknown. We do not know what dark matter is made of, but we have strong evidence that something invisible is shaping reality on the largest scales. A useful way to think about dark matter is as the hidden scaffolding of the universe. Imagine walking into a building and admiring the walls, windows, and lights, only to discover that most of the structural support is inside the walls where you cannot see it. The visible parts tell you what the building looks like. The hidden frame tells you why it stands. In this analogy, stars and galaxies are the visible decoration. Dark matter may be the deeper structure that holds the cosmic architecture together. Another useful metaphor is to think of it as a map beneath the map. The glowing universe, the one we photograph, is like roads, cities, and rivers printed on the surface. Dark matter may be the underlying terrain, the pressure field, the invisible landscape that determines where structures can form. Galaxies do not appear randomly. They emerge along patterns, filaments, and clusters across the universe, as if ordinary matter settled into a gravitational web that was already there. This leads to one of the most important ideas in cosmology. Dark matter likely played a major role in the formation of galaxies. In the early universe, matter was distributed more evenly than it is now. Tiny fluctuations in density gradually grew over time. If there were only ordinary matter interacting with radiation in the early universe, structure formation would have been too slow or too messy to match what we see. Dark matter provides a cleaner explanation. Because it does not interact with light the way normal matter does, it could begin clumping earlier, creating gravitational wells into which ordinary matter later fell. In that sense, dark matter may have prepared the stage before stars ever lit it. Dark matter also changes the way we think about emptiness. Space is not just a blank container with a few bright objects floating inside. It is a dynamic environment shaped by things we cannot directly perceive. What looks empty may be gravitationally full. What looks secondary may be fundamental. Human intuition struggles with this because our brains evolved to track surfaces, edges, movement, sound, and visible cause and effect. We trust what reflects light. But the universe is under no obligation to organize itself around our sensory preferences. There is also a deeper philosophical tension here. We often assume that seeing is the same as knowing. Dark matter breaks that assumption. It reminds us that science is not limited to what is immediately visible. Science often works by tracing consequences. We do not see gravity itself, only what gravity does. We do not see magnetic fields directly, only how they move other things. In that sense, dark matter belongs to a long tradition in science. Reality inferred from structure, not from appearance. Of course, there is still debate about the exact explanation. Some scientists have explored whether gravity itself might behave differently on cosmic scales, leading to modified gravity theories instead of unseen matter. These alternatives are taken seriously and tested rigorously. But so far, dark matter remains the most widely supported framework because it explains multiple independent observations at once: galaxy rotation, cluster dynamics, lensing, and large-scale cosmic structure. So what could dark matter actually be? No one knows yet. Candidates have included weakly interacting massive particles, axions, sterile neutrinos, and other hypothetical particles beyond the standard model of physics. Massive underground detectors, satellite experiments, and collider searches have all tried to catch evidence of these possibilities. So far, the search has been frustrating. We see the fingerprints, but not the hand. We see the gravitational shadow, but not the object casting it. That uncertainty is not weakness. It is where science becomes most alive. We are not dealing with fantasy. We are dealing with a real effect whose source is still hidden. The map is incomplete, but the missing territory has shape. If this understanding is true, then the visible universe is only a thin layer of a much larger reality. That has huge implications. It means the cosmos is not mainly made of stars, planets, nebulae, or anything we emotionally associate with space. The glowing universe may be the minority layer. What feels central to us may be structurally secondary. It means our models of reality must stay humble. Human beings discovered dark matter not because we saw something strange directly, but because our equations kept telling us the visible story was insufficient. That is a powerful lesson in intellectual honesty. Reality does not care whether it is intuitive. It means the formation of galaxies, including the one that eventually gave rise to Earth, may have depended on an invisible gravitational framework that existed long before life. In a very literal sense, our existence may be downstream of something we still cannot identify. It means there may be entire sectors of nature that barely touch our ordinary senses, not because they are mystical, but because they interact through rules different from the ones daily life has trained us to notice. The universe may be richer not just in size, but in category. And psychologically, dark matter offers a strange kind of practical wisdom. It suggests that unseen forces can still be real and decisive. In human life, not everything that shapes an outcome is obvious on the surface. Hidden structures matter. Habits, assumptions, emotional patterns, systems, and environments often shape visible results long before the results appear. The cosmos may be teaching the same lesson at a larger scale. What is invisible is not necessarily unreal. Sometimes, it is the reason the visible world looks the way it does. Dark matter is one of the clearest reminders that science is not just a catalog of things we can point at. It is a discipline of following evidence wherever it leads, even when it leads beyond common sense. The night sky looks full of brilliant objects, but the deeper truth may be that most of the structure behind them cannot be seen at all. So when we ask what dark matter is, we are really asking something even bigger. How much of reality is hidden behind the things we mistake for the whole picture? We still do not know what dark matter is made of, but we know the universe behaves as if it is there. And that may be enough for now to force a profound shift in perspective. Lucid Order. Question everything.